Here we go, question number 5, maximum subarray. We are given an array, we have to return the subarray that has the largest sum possible. We don't have to return the elements of subarray, but the sum itself. Now, what is a subarray? Subarray is consecutive sequence of elements. For example, 4 minus 1 to 1. It is a consecutive sequence. You cannot take 1 from here, 4 from here, 2 from here, and another 4 from here and say that your sum is 11. No. Elements has to be consecutive. If it was maximum subset, then you can take it. But it is maximum subarray. Alright? So you can implement this by using brute force approach of n square time complexity, where you traverse through all possible subarrays and keep a track of the maximum sum. But we are going to do it in linear time complexity with the help of Cardan's algorithm. For this, we have to keep a track of two variables, current sum and maximum sum. Then what are we going to do? We are going to traverse. All right, you have to initialize the maximum sum. You should with the 0th element. Well, it's fine even if you don't. No, actually you have to. Suppose all the elements are negative, then the maximum sum is not 0, but the negative, right? So you have to initialize it with first element, or you can initialize with int mean. That's fine. All right, but we are initializing it with the first element. And in the constraint, it has stated that at least array has one element. Otherwise, we couldn't do this, right? So let's traverse. And now add the current element to the current sum as usual. Cardan's algorithm is actually a logic of only one statement that we are going to see soon. Current sum plus is equals to the current element, that is nums of I. Then update the maximum, that is the maximum that is previous maximum, or the current sum, whichever is the maximum will be stored in the max sum. And if the current sum becomes less than 0, then we are going to reinitialize it to 0 itself. Why? Let's see. Suppose in the first thing the current sum is minus 2. Okay, so the maximum will also be minus 2. Then the currents, now we are now the current sum is less than 0, right? It is minus 2. So we are reinitializing the current sums to 0, because it doesn't make any sense to use this minus 2 and go further, because it will decrease our largest sum possible, right? That's why we are going to reinitialize to 0, so that we can fresh start from 1. Now the current sum would be 1, and the maximum sum is also 1, because 1 is greater than minus 2. Then the current sum is greater than 0. I mean, yes, it is greater than 0. Then we are not going to reinitialize to 1, reinitialize to 0. We're not going to do that. Okay, then minus 3. 1 plus minus 3 is minus 2. The maximum will stay at 1. And now, if we go any further, this minus 3 is hurting us, because our current sum itself is negative, and it makes no sense to carry it any further. That's why we are going to reinitialize it and fresh start from 4. And similarly, 4 plus minus 1 is 3. 3 is not less than 0. That's why we are going further. 3 plus 2 is 5. Now 5 are also not less than 0. That's why the maximum will be 5. And we are going further with that current sum. 5 plus 1 is 6. And it is also not less than 0. So 6 is the maximum. And we are also going further. Now 6 minus 5 is also not less than 0. It is 1, right? So we are going any further, but the maximum sum will not be updated, because the current sum now is 1 and maximum is holding 6. And then we are going further. 1 plus 4 is 5, and the current sum is 5, and maximum sum is still 6, because 5 is less than 6. So this is how it is working. We don't have to take as many elements as possible. See, we have to return the largest sum, right? And let's try this. Okay, we didn't return anything. Return maximum sum. And it's working perfectly fine. Let's submit. and it's beating 100%. It's the most optimal solution. All right. So that's it. Thank you.